All right, good morning, guys. This is March 7th for KAP. We're going to start with a little brain pop video today. We're going to start talking about inequalities, which hopefully you remember from elementary, but we're going to start with a brain pop video just to refresh us. So here we go. Oops, I'll start over.
Well, it's not really called lobster hunting because we just set traps for them. Too small. Dear Tim and Moby, what is an inequality and how do I make one? From Lily. An inequality is a mathematical expression that shows the relationship between quantities that are not equal. Inequalities use a set of symbols that are greater than, less than, greater than or equal to, and less than or equal to. There's an easy way to remember these symbols. You can think of an inequality symbol as a hungry mountain that's always trying to eat the bigger number. We use inequalities on the boat to figure out whether or not our lobsters are big enough. Now, there are rules in lobster fishing. To keep a lobster, its body, the carapace, has to be at least 8.26 centimeters long. The words "at least" tell us that we're dealing with a greater than or equal to relationship. If we call the lobster's measurement x, then x has to be greater than or equal to 8.26 centimeters. That means it can be exactly 8.26 centimeters, or it can be larger. Let's check it. 9 centimeters. 9 centimeters is greater than or equal to 8.26 centimeters, so we can keep this one. Oh, wait a second. This here's a female lobster. She's got eggs. We have to put her back. Oh, that's not a math thing. That's a lobster fishing thing. Bye-bye. Whoa, what a monster. I'm not sure you want to handle that guy. This might be a good time to talk about the maximum size. Any lobster we catch has to measure at least 8.26 centimeters. That's the minimum size. But it has to measure less than 12.7 centimeters. If it measures exactly 12.7 centimeters, then it's too big. So this new lobster's length, which we'll call y, has to be greater than or equal to 8.26 centimeters, but less than 12.7 centimeters. 15.5 centimeters, that's greater than 12.7 centimeters. Sorry, Moby, this just isn't your day. Put him back in the water. Whoa, he got you. Moby? Wow, are you alright? Well, give me your other hand. I'll help pull you into the boat. Oh dear.
Alrighty. Okay, oops. All right, so take a few seconds trying to talk to a partner. If you're at home, just talk to yourself. What does the word inequality mean to you? Pause and play. Okay. So hopefully inequality, if you look at that word, you probably said something similar to like inequality sort of means like not equal to. Okay, when something is greater than something or when something is less than something, it's not equal, but it's more than or less than. As you saw in the video, it does have, we're going to explore into inequality symbols where it can be exactly that much, but then again, greater than or equal to, and then less than or equal to. All right, so hopping into notes. So just as a review, hopefully some of that we've heard before. I'm talking about an inequality is a mathematical sentence that compares two quantities. It says that this side is bigger than this side is less than the other thing. Okay, it compares two quantities that are not equal. They're very similar to equations, so I could say like, we'll do some examples in a second. Okay, if a value is, if something is a solution to an inequality, just like within equations, a solution makes it true. Okay, when you plug it into the inequality, it makes it true. So just a quick review first of all the different symbols. The less than symbol goes this way, greater than is the other way. Something that's a little different is the less than or equal to. So it's still the less than symbol, but then they put this equal, like a bar underneath it. So it sort of looks like the equal sign, but then it's a combination too. It's like the combination of an equation, equal sign and a less than sign. On the greater than or equal to, it's the flip with a line. Okay, so let's talk about like some word examples. So less than, fewer than is something similar. You could say must be less than. You must be less than 3 years old to get a kid's meal. I don't know. You must be under. There's lots of examples. Under. I should say under. Oopsies. Okay. So like for example, 3 is less than 5. That is a true statement, and you would read it left to right. Whenever you get inequalities sort of confused, we always read left to right. So 3 is less than 5. The other way around, greater than, some examples. I'm going to make my marker a little skinnier so I can write. Greater than, more than, must be over. Must be over. So like roller coasters, you must be over, I don't know, like 48 inches to ride. Okay, so that means 49 works. 48 doesn't work. I know a lot of times they let you ride anyway. Okay, 10 is greater than 7 is an example. A cute little thing to remember, a student shared with me once, the less than symbol, you can turn it into the word less than. So cute. And then the greater than symbol, they said, oh, I can make that into a G, greater than. I think most of y'all have got it, but those are cute little things. Greater and less than goes the other way. Okay, so let's look at these two new ones. So again, less than or equal to, some word examples, no more than. No more than 13 people can fit in the car. So exactly 13 could fit, but no more than. If I said 14, it doesn't fit. 11 fits, 12 fits, but no more than 13. Okay, so we're going to spice it up. I'm going to throw some variables in here. So x plus 3 is less than or equal to 10. So let's talk about what are some numbers I can plug in for x. If I plugged in 4 plus 3, is that less than or equal to 10? Yeah, because 4 plus 3 is 7, and 7 is less than or equal to 10. But the cool thing about inequalities is you can have more than one value be x. I could plug in 5, I could plug in 6, and it keeps, and it keeps working. Okay, so with inequalities, they'll have more than one solution. We'll go into that a little bit deeper in a second, but let's just focus on these examples. Moving on, greater than or equal to, at least. So you must be at least, I don't know, like 16 to drive. You must be at least 16 to drive. We all know you can be exactly 16 and drive, or you can be older. You can be no less than. You can be no less than 16 to drive. Okay, so I can flip this inequality around. I can say x plus 3 is greater than or equal to 10, and x would be other options. So if I need this side to be greater than or equal to 10, I could plug in 8. 8 plus 3, that gives me 11. Oops, x, 8 plus 3, that's 11, and that would be greater than or equal to 10, so that works. If I plugged in 7 plus 3, is that greater than or equal to 10? That gives me 10 exactly. 10 is greater than, yeah, that works. Okay, if I plug in 7, it actually works because of that line underneath. It can be exactly equal to. Again, we're focusing more on the words right now, but understand that we're going to be spicing things up. We're going to be looking at some equations in our inequalities. Okay, so let's just practice writing. Whenever I write my inequalities, again, it's a comparison of two things. It compares two quantities. So I'm always going to have one thing on one side of the inequality symbol and another thing on the other side. So let's do, let me do a couple and then I'll let you do a few on your own. So it says you must be over 12 years old to ride go-karts. So you must be over 12 years old. So because inequalities can have more than one thing, I'm going to say first we're going to compare like my age. We're going to use a variable. So I'm going to say A is talking about my age. Now, what am I comparing my age to? I'm comparing it to 12. So I always say like A on one side, 12 on the other. Okay. If I must be over 12, that means that it's going to open up to this side because A, my age needs to be greater than 12. Okay. Then ask yourself, can I be exactly 12 and go in this? Would I add a line to this? If I must be over 12, I can't be 12 and go on this go-kart. I have to be older than 12. So 12 doesn't work, but 13, 14, 15, all that stuff. So this is my inequality. Okay? Second one, you must be at least 16 years old to have a driver's license. So again, I'm talking about my age. I'm going to be comparing my age to 16. I'm going to have this on one side, this on the other. My age has to be at least 16. So can I be exactly 16 in order to drive? Yes. So I'm going to have a line in my inequality because I can be equal to. But then it needs to be at least 16 years old. So can it be greater than 16 or less than? The answer is greater than. So it's going to open up to that side. Keep in mind that you can also switch this around. If I put 12 on this side and A on the other side, we just need to open up to the same thing. So this is opening up to the A. That's another way to write it. Same thing here. If I compare 16 and A, again, it's still equal to, but my age could be greater. So it would be 16 is less than. Okay. I'll do one more and then I'm going to, okay, do the next one. Try number 3, pause and play when you're ready to check. Okay. Still, we're comparing our age. And we're comparing our age to 13. You must be no less than. Okay. No less than means more than. Can I be exactly 13? Sure. Okay. I just can't be less than it. So I have to be greater than or equal to play it. There's a lot of greater thans in this. Okay. Let me do the next one. The quotient of x and 3 is less than or equal to 5. Oh, that had a little bit more. So the quotient, hopefully you know that the quotient, that word is associated with division. The quotient of x and 3. So I need to divide x and 3. And they're saying that quotient, that answer, is less than or equal to 5. The quotient of x and 3. So I can write the quotient, I'm going to use it as a fraction, x and 3. The quotient of x is 3, and I'm comparing that to 5. It says that is less than or equal to. It is less than or it is equal to 5. Try the next one. Pause and play. Okay, it says the difference. So that means subtraction. The difference between x and 4 is greater than 10. X minus 4 is greater than 10. Cool. Hopefully you're doing pretty good. Okay, that's just writing the inequalities. Next, we're going to evaluate. Again, that just means solve whether a value makes an inequality true or false by testing solutions. Again, solutions make things true. So I'll do one and then you do one. It says of the given values 6, 7, or 8, determine which values makes the inequality f plus 2 is less than 9 greater, or f plus 2 is less than 9. I want to see if I plug in these values for x, which ones make it true. So first I'm going to substitute. So I'm going to replace f with 6 plus 2. Is that less than 9? I'm going to replace it with 7 plus 2. Is that less than 9? And then 8 plus 2. Is that less than 9? Okay, I'm first substituting and then let's solve it. Evaluate, solve. Okay, 6 plus 2 is 8. Is 8 less than 9? Yep. 7 plus 2 is 9. Is 9 less than itself? It's equal to itself, but it's not less than, so that doesn't work. And then that gives me 10. That doesn't work. So the only one that makes it true is 6 makes it true. Okay, pause and play. Try that next one. Try it on your own. All right, which ones make it true? You should have, if you did 8 minus 3 is greater than 6, that's 5 is greater than 6. Oh, that's not true. 9 minus 3 is greater than 6. That gives me 6 is greater than 6. Nope, still, it can't be greater than itself. 10 minus 3 is greater than 6. That's 7. Oh, yeah, that one works. So 7 makes it true. Or, sorry, not 7, 10. 10 makes it true. So again, when it makes it true, those are called solutions. It is a solution. 6 is a solution. 10 is a solution. All right, moving right along. Okay, We're just touching a lot of things, touching on a lot of different things for inequalities. So we talked about writing inequalities, talking about solutions to inequalities. We are also going to talk about graphing inequalities. If you took the blue group pre-assessment, you might have seen these little graphs, and now hopefully we'll explain it. Okay, so we're going to talk about how to graph the 4 different inequality symbols. Whenever I graph it, we see that x is less than 5. So let's just talk about that. What are some values that I could put in for x? I could say 3, I could say 4, I could say -2. Okay, those are all values that are less than 5. 5 isn't true, but the rest of them are. Okay, so the way to graph that with inequalities, again, I'm noticing that I have more than one answer. So unlike the number lines with the equations, it's not just one dot, it's going to be a multitude of answers. So when I graph it, I'm going to start with putting the number 5 on here. Okay, when I have x by itself, I'm going to have 5, and then I like to put a number on either side. So I'm going to put 3 on this side, and then I can put, 7 on this side. Okay, I always start with 5. Can I put in 5? Is 5 less than 5? The answer is no. And so because of that, I'm going to put an open circle. I'm going to explain the open circle in a little second, but it's going to be an open circle. We're then going to have an arrow that either goes this way or that way because it's multiple answers. So ask yourself, okay, if I put in 7, is 7 less than 5? No. Any number this way, 6 doesn't make it true. 8 doesn't make it true. No numbers on this side of the number line make it true. What about the other side? If I plugged in 3, is 3 less than 5? Yep. Okay, what about like a number closer? 4, is that less than 5? Yep. With all of these numbers, okay, we can get into the nittiest grittiest like decimal. We could say 4.9999999. Is that less than 5? It sure is. Okay, so that's why we put an open circle, and then we're going to draw an arrow going this way. So it's saying all of the numbers this way from 5 this way. We just can't include 5 because it doesn't make it equal to. Okay, let it sink in. Okay, moving on to the next one. I'll change colors. X is greater than or equal to -8. So again, I'm going to start with -8, and then I'm going to put a number on either side. Now we're in the negative, so be careful. Don't let it trick you. Okay, a number on this side would be -9. A number on this side would be -7. Okay, start with 8. Can -8 be greater than itself? The answer is no. Okay, but let's talk about which direction. Okay, so remember, back in the beginning, we say less is on the left, greater is on the right. So if I put -9, is -9 greater than -8? No, we went left, we went less. That doesn't work. If we went over this way, -7, that is greater than -8. If I put in -7 right here, -7 would work. Okay, if I put in like a number here, that would work. I could get so close to 8, like 8.000001. Or sorry, 7.9999999. That would work. I'm so close to 8, but 8 itself can't be it. So I'm going to leave an open circle, and then I'm going to do an arrow this way. All right. So when it's not equal to, when it's just less than or greater than, it's going to be an open circle. Let's look at how things are going to change over here when it's like less than or equal to. Okay, starting again with that number that's in my inequality. Okay, so -2, putting a number on this side again, it's negative, so -3 is over here, -1 is over here. If the negatives throw you off, I know that over here I have like, I don't know, positive number 8. That can help you. So if I plug in those numbers, -3, is that less than -2? I think so. But let's check if you need a positive number. Is 8, positive 8, less than -2? Oh no, that doesn't work. So I know it's not going to be any of the numbers this way. So I'm going to have my arrow going that way. Now let's talk about -2 itself. If I plugged in -2 is less than or equal to -2. -2 is less than or equal to -2. Would that be true? Yes. Okay, it can be equal to itself, so it can be -2 exactly. So when I can include that number in the answer, we fill in that dot. Okay, again, open dot because I couldn't put 5 is less than 5. But in here, because it can be equal to, I can include that number. Okay, just one more for fun, I guess. Putting 10 on here and then a number on either side. I'm going to go 9, I'm going to go at 11. Which one of those numbers would make it true? Is 9 greater than or equal to 10, or is 11 greater than or equal to? The answer is 11, and then ask yourself, would 10 work? Okay, 10 is greater than or equal to. 10 would work, so we would include 10, and then we're going to include every number going that way. You use an arrow showing that it's going to go on forever and ever and ever, because it has all the solutions going that way. Okay, so again, if it has the equal to, if it has the bar, it's going to be a filled in dot because it's included. If it's open circle, that means it's not included because it can't be exactly equal to. Okay, so what I want you to do is practice graphing these. Pause and play when you're ready. Okay, I see exactly 9. I asked myself, can it be 9 greater than 9? The answer is no, so it's going to be open. Which number does work? Does 10 work or does 8 work? The answer is 10. Next one, can I include 8? Is 8 less than or equal to 8? Sure can. It is equal to. Which direction? Which one is less than 8? This way. A is less than 15. Can I include 15? Nope, it can't be less than itself. But all the numbers less than 13, 14, all that. It's going to go all that way. And lastly, B is greater than or equal to 7. Can I include 7? Sure can. And then I want all the numbers greater. Okay, so if you need to copy those down, pause and play. Lastly, of course, we can do some word problems. So let's do a couple on your own, and then it'll be partner practice. So the number of text messages Layla sent each month is shown on the table, and she can send no more than, keywords, no more than 55 text messages. I'm already going to think about that. Can I send exactly 55? Yeah, but I just can't send any more than that. Okay, got it. Each month, so no more than 55 messages each month without being charged. Use the inequality right there. They gave us the inequality. How nice. Where T is talking about the number of text messages in a month to determine in which months she exceeded means go over her limit. If additional text messages cost 25 cents, how much was Layla charged from January to April? So this is like a two-parter. First, we need to determine which months she went over her limit. Her limit, again, was 55, so when did she go over? I see January and February. January and February, she went over. Okay, those are when she exceeded. If each additional text message cost 25 cents, how much was she charged? So for each additional, so how many over did she go in January? She went 1 over. In February, she went 2 over. If each one costs 25 cents, I'm going to multiply that by 25. I'm going to multiply that one by 25.25, sorry. Okay, and then I'm going to end up adding those. You might have written a different equation, but that's an example. So we would have like 25 cents plus 50 cents. In total, she's going to be charged 75. Y'all might think that's not that much, but it adds up quickly. My parents used to get on me. Okay. And lastly, if A is greater than B and B is greater than C, what is true about the relationship between A and C? What is true about the relationship between A and C? Okay, if A is greater than B. I don't have any numbers, but I can always plug in some numbers. If A is greater than B, I'm going to say, let's put some A, B, C values. Let's say like, I don't know, 10. A is 10. And if it's greater than B, B could be 8. Sure. Okay, if A is greater than B, that's true. And then B is greater than C. Okay, B is greater than C. Let's make it 6. I don't know. It could work. What is true about the relationship between A and C? Okay, hopefully we can say, okay, well, if A is greater than B, we agree that 10 is greater than 8. That works. Okay, B is greater than C. So I'm just coming up with my own numbers. 8 is greater than 6. So what could we say about 10 and 6? We would say that 10 is greater than 6. So if I change that back, 10 we said was A, and 6 we said was C. We could say that A is greater than C. Okay. Again, my reasoning is because I plugged in some numbers and I defended my answer. Okay. Last problem. Okay, if x is equal to 2, is the following inequality true or false? So I'm going to substitute it in for x. I'm going to replace x with 2. I'm going to solve both sides and see. So 112 over 8 plus 2 is greater than or equal to 15 plus 4 times x. We said was 2 minus 7. Ugh, I got some math. So I'm going to solve this whole side. I'm going to solve this whole side, and then we're going to compare. Order of operations says I need to divide first. 112 divided by 8. Left with 32. Again, if I'm going too fast, just pause the video as needed. Okay, so that's 14 plus 2. That's going to give me 16 in the end. All right, over here, order of operations, I need to multiply first. So that's going to be 15 plus 8 minus 7. When I have them happening at the same time, we do it left to right. So that's going to give me 23 minus 7. 23 minus 7. 1, that's 13. That's going to give me 16. 16, is that greater than, I'm just writing this symbol down, is that greater than or equal to 16? It sure is. So does it make it true or false? The answer is true. Okay. Awesome job. Now what you're going to do is you're going to do some partner practice. You can work with one person. In a few minutes, we'll go over those. Pause and play when you're ready. Okay. Here is that key. Again, if I go too quick, just pull it up on Canvas. Oopsies. Alrighty, your homework tonight is that back page. Thank you and good night.